In this video, I'll be doing this same intersection in a slightly different way, in the semi-automated way provided by Civil 3D in the intersection command in here. So I'll open a new file, which is, we'll call it method 2, exactly the same as the base file of our intersection. Again, I'll highlight on the important aspects of this design. We are designing a intersection for a urban design. In other words, I'm looking at the intersection between two roads here. It's important to note this is an urban design. In other words, the design of the profile, one of the main things that we can notice, the design of the profile, it has been designed in a way that the proposed profile, the blue line here, as close as possible to the existing ground profile, preferably below the existing ground, because in urban designs the road usually provides a drainage solution for the surrounding grounds, because that's where the infrastructure is placed in the road. So if there's any runoff from surrounding blocks of lands, or residential blocks or commercial, that will run off to the road, and then we've got the side entry pits that will collect all of those to our network. So that has been said, if we are designing for a rural design or a road design for a highway, it will be the opposite. So we should eliminate the amount of water coming from the surrounding grounds into our road. In other words, if we have our road in a cut arrangement like this, it's below, if we are forced to create a cut area where the road is below the surrounding grounds, we should provide some kind of drainage channels, we'll call them the table drains, on both sides of the road to allow for the water to be drained. That water may come from the road or may come from the surrounding ground. The main thing, our goal then, is to keep the road dry, because usually on rural roads or highways, cars and vehicles are traveling in high speed and the friction is very important, so we should maintain the road as dry as possible. As we agreed, completely different aspects or parameters of design for a rural road comparing to an urban road. If we are looking for a rural road or a country road or a highway road, we have to look mainly into the vertical, horizontal curves, the K value of the vertical curve, the radiuses of the horizontal curves. We have to make sure a good ratio between cut and fill being achieved to create efficiency with the construction. So these are the main criteria for an urban design. We try as much as we can simply to be as close as possible to the existing ground to minimize the amount of cut and fill. And also, we're not really too cautious about the speed of the vehicles traveling in these roads. We're expecting vehicles to slow down and to be more aware of their surrounding in urban developments. That's what will create the additional road furniture or structures that we see on the road to create small roundabouts or barriers to give their perception for the driver to slow down. Okay, if you have any issues with dice, you can check the previous video, we talked about that one too. So long story short, simply for urban design, let's keep the profile as close as possible to the existing grounds. In terms of the cross section of the road, again, I have the same cross section what we had in the previous video. Simply if I measure the measurements here, or I can just select that lane to get the measurement. It's 3.6 meters wide and negative 3% crossfall. So that means this point here is lower than that point there at a gradient of 3%. Let's keep that in mind. We will need them for down the track. As we agreed, the first thing to create the intersection, we have to space the two corridors. So that's the first corridor. We can simply just slide it to the back to create the space for the intersection to be constructed here. I'll just hide the points. And for this corridor here, we have to create a small region here, and that region has a slightly different cross section there. In other words, if I am traveling on the direction of the alignment, that's 280, the station here, 280, and I've got 300 here, that means the alignment's traveling this way here. if the car is dropping on the alignment this way, when I turn to the left here to go to the other road to alignment 2, I shouldn't go over the curb, the sidewalk and the daylight, which is they are here on the left hand side on my road. So I have to create a new cross section just for that region that doesn't have these components on the left hand side. So I'll copy this, just select that and go to home and copy from there, because I don't want to copy sub-assemblies, the whole assembly. I copied it there, and simply I have to delete all of this on the left hand side. I'll call this one road junction RJ, and because I'm turning to the left hand side, this is my name convention. You can choose any name convention as long as you choose something that you remember and that makes sense. Okay, so I've got that. So to add this cross section in here, I don't want to add it to the entire road, just for a small region. I have to create that region just by selecting the corridor here, split that region around here and this region here around there. That created a small region between them. For that region I have to modify region, and go to region properties and change that region in with the cross section to road junction left hand side. As you can see, I eliminated that side, gutter, road gutter, curb and sidewalk. Okay, so we have the space now. What we can do, that's where we use the automated process from Civil 3D to create the intersection geometry only. We're not going to use fully utilize it, because that will create very complicated cross sections. Usually I'll find them very time consuming to fix them at the end. So before I do that, I have to stop one of the functions on Civil 3D. If I go to the settings and go to intersections, so I'm using the intersection command from Civil 3D, I have to go to the commands there for creating intersection. I have to go to these commands and stop Civil 3D from changing my profile. So the second road profile, I don't want it to change that. I'll do this changes if needed. Okay, remember to do this step here. Okay, so I got that sorted. Now to create that intersection, we'll create an intersection and we'll ask me where do you want to create that intersection. I'll just turn the snap off as usual. Shift right click in point of that alignment. I'm just coming close to this alignment here. Before I did that, I made sure these two alignments, they definitely intersect at that point. So that's where we want our intersection, and that will start the process of creating that. That will call intersection 1, 2, 3, wherever, how many intersections you're creating. So the next counter, I'll keep that, that's fine. All of this here, it's all good. They are just basic properties. Now, one of the important things that you can note from here, that it's asking you which ground you want to maintain. Do you want to maintain the main road, the continuing road ground, or do you want to maintain both roads grounds, something like that, for a 4 roads intersection? That's not what we want. We want just the main road. We have a T intersection. We want the main road to maintain ground, the secondary road just to finish to where the elevations of the side of that road. Okay, so to maintain the drainage on the side of this main road. So we'll go to next. Just check what alignments has been chosen. So the main one is alignment 1, and that's what we wanted, because that's alignment 1 and that's alignment 2. So the main has the higher priority, which is priority 1, is alignment 1. Make sure the proposed profiles has been chosen, not the existing ground profile. If you have any issues with that, you can change them from here. That's the area where the steps that we did before manually, the software will help you to get that done. So it's creating the offset alignments, to create the what we call them, the connection or connected alignment. It's called curve return alignment here, and just a few other settings that we're going to go through one by one. So the offset parameters, so it's asking us for our offset parameters. As we agreed, we want them to be offset at 3.6 meters wide on all sides for the 2 roads, for the second road and the main road. If you have different arrangement for your roads, different widths, you can choose different offsets for each alignment, alignment 1 and alignment 2. And I'll go OK. And for the curve return settings, again asking us here for this curve return, it's worth noticing Civil 3D chooses the direction always clockwise too. So the direction here, the rotation is clockwise, as you can see. Keep that in mind, we will need it down the track. And the name convention is very similar to what we chose in our previous video. It's called here as a northeast. There we go. So that's the northeast quadrants. Okay, we chose it before northwest. It's chosen by the software northeast. That's fine. So as long as we know which one it is, and importantly to know the radius, we want it to be 9 meters, not 10. Don't forget, before you exit that, to go to the next quadrant, which is the second side here, showing you where's the second side on this right side here. Again, it's clockwise direction, and just make sure that you choose to be 9 meters. Okay, there's no other changes that we have to do here. And then we have to go to the laying slope parameters. That's now for the profile. So we fixed for the width side or for the alignment side, and then with the profile, as we agreed, we want our profile to be -3% from the ground point. So not 2%, -3. And I'll keep the name convention the same. Make sure you change them all to -3%. I'll choose OK. And this is the last setting, which is not very important really. It's just asking you how much the overlap do you want between this new line that we're creating here and the offset parameter, offset alignments that we will be creating. 10 meters would be sufficient, shouldn't be a problem. Okay, that's our setting. That's kind of saving us from doing the steps of the offset alignment and the connected alignment. Not much, but it's the same thing. This is the third part, to create the corridor for your new intersection. The thing is, I don't usually allow software to do that. The reason, when the software will be doing this, the Civil 3D will be creating all these cross sections for us, and usually it's creating different cross sections than what we're using from different properties. And I found it to go back and fix them all to what we want them to be done. It's kind of time consuming, and just there's larger margin for error. So I prefer, I don't create the corridor with the software, I create it myself, unless you have your own setting being done before and refined and you can save them, and that's the time where you can just utilize them in future times. So I'll ask the software not to create the corridor for us, we'll create it ourselves, and that will create mainly the geometry. As you will see, that created the geometry of our cross intersection. Okay, so created the 2 offset alignments, and that's the 2 offset alignments for the second for alignment 1, and then created a connected alignment between them. So this is just the symbol and the label of the intersection. You can delete the label. It's not good idea at all to delete the symbol here. The reason, if I delete that, that will delete lots of parameters connected to these new lines that has been created. So these lines are all connected to this symbol, which is called intersection 1. So make sure that you don't do that, because that will allow you to go back and fix some of your settings for that intersection. And if you delete that, all of those will be connected to something that doesn't exist, so that will create lots of issues for your design. So you have to keep that simple there. Okay, so we created the outer geometry, and then we go back to what we did before. Simply, I can go to my corridor and add a baseline. That baseline, it will be intersection quadrant northeast or southeast, one of them. So I'll add that, and we'll ask me, it will give me the one profile for that, which is this one here. And then I'll add another baseline, which is the last one, and that profile for it. So the same what we did before. I'll do all the steps that we did before. I'll fix all the parameters on this corridor. So that's the two baselines that we added there. I need to add regions. Okay, I don't have the cross section for that. So keep in mind what we said about this, that this has been created clockwise. So this is the rotation here, and that's the rotation there. Again, when you think about this, imagine that you are walking on this curb line. You should be seeing the curb, sidewalk, and the daylight to your right, and the lane to your left. And that's what we need. So lane to the left and everything else to the right. So if I create one of those, I'll copy this. Lane to the left, this should stay. All of this, don't need it. And all of that to the right. I don't need the lane to the right. Okay, so we'll call it curb return right hand side, because the curb on the right, that's the name convention I use. So curb return right hand side. So if I go back to my corridor properties, for these two, I need to add the cross section there, which is curve return right hand side, and that should apply for both of them because both are rotating clockwise. This is the advantage of making all your rotation in the same direction. So I'll fix the frequencies to start with at 1 meters mainly, and I'll go to fix the targets. So the targets, as we agreed, on both outer edges. So I've got the daylight on one edge should target the existing ground, and the lane on the left hand side should target two things. So I'll go to the drawing so I can show you those. That will be, so I'm working with this one here. If there's a lane here, should be targeting either this line here when it comes to this point, should be targeting the alignment 2, or when we come to this point here, shouldn't go all the way to alignment 2, should stop by this line here, which is alignment 1, left hand side. So I'll choose that, enter, alignment 1, left hand side, add it, and alignment 2, add it. So I'll do the same. As long as you choose them once, you know exactly what you want, you can choose them again. Make sure for the profile you choose the proposed profile, not the existing ground profile. That's our targets in this area here, and I'll fix the targets for the last one here. Have all our targets correct now, and our frequencies are already done. If you'd like, you can change the frequencies for the main roads just to make it a bit more accurate to 5 meters. And apply, rebuild the corridor. And okay, so it looks like my frequency here in this area are not very great for some reason. I can change these frequency for this part here. For some reason, what I have them here around the curves, so I'll just make them all at 1 meters. Then change all the frequencies, and I'll change the frequency here to be all at 1 meters. Okay, so by doing that, as we agreed, I still have one area there that needs to be corrected, which is that center area, and I can do that manually by just adding sections there. So I want the section to be here, shift right click intersection, that point, enter, and add a section here. Some precision, and we're done. So as you can see here, if I try to close these corridors here, can see there's some minor issue. We'll check it in a minute. They look good around this area here and that area, as we agreed. As long as they match with the existing roads, that means we've got a accurate enough intersection. And I'll slide this corridor here to be at this point. And that one there. There we go. So we've got good connection between the existing corridor and the proposed corridor from the intersection. And if you'd like, you can create the surfaces quickly for that. Corridor surface, add, don't forget the boundaries, rebuild the corridor, and I'll do the same for this corridor here. If I look at the two surfaces, I'll go to the prospector, got these two, select, and look at them in 3D. The outcome, for some reason I selected the corridor with it. When you select the corridor, it makes it a bit slower. So I'll just select these two only, without the surfaces, without the actual corridor. And I'll go to the view. As we can see, we've got the intersection done. If I combine these two surfaces, that will create a seamless connection between them here. We have the same issue of what we had before on the side of the curb here. As we agreed, we can fix that if you check the previous video. Alright guys, hopefully that will help you, that to create a road intersection in both different ways. Method number one is manually. Method number two, kind of using the intersection function from Civil 3D. You can try, if you'd like, do the same and follow all the procedure from Civil 3D around here. I'll show you just in a minute. If you follow the procedures from Civil 3D, just select here, in point of that. If I choose another intersection for any reason, just quickly, if you follow the full procedure by creating the corridor, you can try it and see, save your file before you do that, and you see the problems with these cross sections will be created by the software and why I usually avoid doing that. I find it's not very time consuming, especially if you know how to do it. There is something that I could have done just to make it even slightly quicker. When I was working on this area here, I could have matched parameters from the first one, and that would have created almost everything the same quickly. Okay, you can try that, so you can fix everything, targets and frequencies and cross section or region for this area here, and then by matching parameters between this area and that area on the corridor, that will add all of those parameters here, and that will save you a little bit of time too. Alright guys, I hope this will help, and if you have any questions, please let me know.